Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today, for exam P on probability. The number of tornadoes in a given year follows a Poisson distribution with mean 3. Calculate the variance of number of tornadoes in a year, given that at least one tornado occurs. And here's the solution. Let us write n for the number of tornadoes in a year. The probability that at least one tornado occurs is 1 minus probability that n is equal to 0. And it's equal to 1 minus e to the minus 3 times 3 to the 0 over 0 factorial. And that's 1 minus e to the negative 3. Therefore, for n equal to 1, 2, and so on, the number of tornadoes that can occur, given that at least one occurs, the probability that big N is equal to n, given that n is greater than or equal to 1, is the probability that n is equal to n and n is greater than or equal to 1 divided by probability that n is greater than 1. That's the definition of conditional probability. But of course, that little n is assumed to be greater than or equal to 1, so the intersection of the 2 at the top is just the probability that n is n. So this is probability that big N is equal to lowercase n divided by probability that n is greater than or equal to 1. And that's equal to e to the minus 3 times 3 to the nth over n factorial. That's the basic formula for the probability function of the Poisson distribution, with lambda equal to 3 in this case, over 1 minus e to the minus 3, which is what we just established above, is probability that at least one tornado occurs. And then we have the expected value of n, given that n is greater than or equal to 1, is the sum from n equal 1 to plus infinity of n times this probability that we just established. And if we put 1 over 1 minus e to the negative 3 in front, this is the sum from n equal to 1 to plus infinity of n times e to the minus 3 times 3 to the nth over n factorial, which is just the same as the standard calculation of the expected value of a Poisson random variable, except it's missing n equal to 0. But in the calculation like this, where if we take n equal to 0, then 0 times its probability does not contribute to anything because it's 0. So this is actually equal to 1 over 1 minus e to the negative 3 times the sum from n equal to 0 to plus infinity of n times e to the minus 3 times 3 to the n over n factorial. Because, of course, again, when n is equal to 0, this expression that we add up there, n times e to the minus 3 times 3 to the n over n factorial, is just equal to 0. So those two sums are identical. And this sum that we see here is just the expected value of n. So this is 1 over 1 minus e to the minus 3 times the expected value of n, which we know is equal to 3. So this is 3 over 1 minus e to the minus 3. And then we do the same calculation for the second moment, analogous calculation. So the expected value of n squared, given that n is greater than or equal to 1, the second moment, is the sum from n equal to 1 to plus infinity of n squared times the probability that big N is equal to n, which is e to the minus 3 times 3 to the nth over n factorial divided by 1 minus e to the minus 3. And we factor out 1 over 1 minus e to the minus 3. What we have left is the sum from n equal 1 to plus infinity of n squared times e to the minus 3 times 3 to the nth over n factorial. But if we add the term for n equal to 0, nothing changes because n squared for n equal to 0 is 0. So this is equal to 1 over 1 minus e to the minus 3 times the sum from n equal to 0 to plus infinity of n squared times e to the minus 3 times 3 to the n over n factorial. And that's the second moment of n. And the second moment is equal to the variance plus the square of the mean. So this is equal to 1 over 1 minus e to the minus 3 times the variance of n plus e of n squared. And you know that the variance of Poisson distribution is equal to its mean, so variance of n is 3, and the square of the mean is 3 squared. So this is equal to 1 over 1 minus e to the minus 3 times 3 plus 3 squared, and 3 plus 3 squared is 12, so this is 12 over 1 minus e to the minus 3. And therefore the variance of n squared, given that n is greater than or equal to 1, is equal to the second moment minus the square of the first moment. So this is 12 over 1 minus e to the minus 3 minus 3 over 1 minus e to the minus 3 squared. And we can just calculate this. And it's approximately equal to 2.660918. That's answer C. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.